All and welcome to this lecture on solving a linear PDE. In this session, we are going to focus on very important part of the solution process, that is how to find the particular integral. So, talking about the complete solution of a linear PDE, it comprises of or it contains two parts. One is the complementary function and the other one is the particular integral. So this complementary function always deals with the homogeneous part of a linear PDE and particular integral deals with the non-homogeneous part of a linear PDE. Now we are straight away walking into the method 1. So what does the method 1 state to us? The method 1 state to us whenever the function f of x comma y is in the form of e power ax plus by. E power x plus by means what? It is simply an exponential function. That is, in the sense we see some functions like e power x, e power 2x, in that way it goes on. So, in that case, how to solve the problem? See, the partial differential equation or a linear partial differential equation is of the form what? F of d comma d dash whole of z is equal to capital F of x comma. What is the formula to find Pi? Pi is equal to 1 by f of d. In f of d place, what is there here? F of capital D into d dash into f of capital F of x comma y. So simply substitute in place of capital F of x comma y, what we have here? E power ax plus by, isn't it? So simply substitute e power ax plus by in place of capital F of x comma y. And wherever here the two things are there in the denominator part, one is d and one is d dash. So in place of d simply substitute a, in place of d dash substitute b. So whatever the coefficient of x is there, which is called a, substitute in place of d, and whatever the coefficient of y is there, that is b, substitute in place of d dash. To understand the method more practically, I have chosen a problem. The problem goes in this way. D cube minus 3 dou cube z by dou x cube, or in simple terms d cube minus 3d square d dash plus 4d dash cube is equal to e power x plus 2y. Now we shall see how to solve this particular linear partial differential equation. In the previous two videos, I already stated how to solve the complementary function or how to find the complementary function of a linear PDE. In this video, again I recall the things. First, to find a complementary function, what we should write? We should consider the auxiliary equation. Auxiliary equation means what? Wherever here d is there, you put m. Wherever d dash is there, simply put 1. So now, how our equation turns up? It turns up as m cube minus 3m square plus 4 is equal to 0. So, what is the nature of this equation? See, it is not a quadratic equation. It is a cubic equation. See here, m cube minus 3m square plus 4 is equal to 0 is a cubic equation. So, now here you apply the method of synthetic division. You all are familiar with this method. So, it is split into two parts. The two parts are m plus 1 into m square minus 4m plus 4. So, here we obtain a quadratic equation, m square minus 4m plus 4 is equal to 0. So, factorize it. After factorizing, what do you get? M plus 1 into m plus 1 is already there in the previous step, carry over into m minus 2 whole square. So, what are the roots we obtained here? Minus 1, comma 2, comma 2. So, here minus 1 is a different root when compared with 2, comma 2. So, here we have two equal roots, 2, comma 2. So, totally how many roots are there? 3 roots. So, how did I write my CF? Z is equal to f1 of y plus x plus f2 of, here y minus x should be there, plus f2 of y plus 2x plus x into f3 of y plus 2x. Now, we shall go to the complementary particular integral part. So, coming to the particular integral part, so what is the formula we have to take up? We have to take up 1 by f of d into capital F of x comma y. In f of d place what is there? F of capital D comma d dash. So what we should write here? D cube minus 3d square d dash plus 4d dash cube. So here, what is the coefficient of x here? In e power x plus 2y, it is 1. What is the coefficient of y here? It is 2. So just substitute 1 wherever d appears to you and 2 wherever d dash appears to you. So substitute in the above equation. So after simplifications, what do we obtain? 1 by 1 minus 6 plus 32 into e power x plus 2y. So when we add and subtract the things in the denominator, finally we are left with 1 by 27 e power x plus 2y. So in this way we obtain the complementary function and the particular integral also whenever an exponential function is present in place of capital F of x comma y. Now we shall go into the second method, which deals with the trigonometric parts. That is, in place of capital F of x comma y, I have chosen sine of ax plus by or cos of ax plus by. So in place of f of x, what I have chosen? I have chosen trigonometric functions. Previously what I have chosen? I have chosen exponential function. In this case we shall see how to solve the equations. So as already the rule states, we have to write 1 by f of d into f of d comma d dash into sine of ax plus by or cos of ax plus by. So in place of d square you put minus a square, in place of d dash you put minus ab, in place of d dash square you put minus b square. So now we shall take a problem and solve the given equation. What is the problem? It goes in this way: d square plus 4d dash minus 5d dash whole square whole of z equal to sine of 2x plus 3. So what is the first step we have to write? We have to write the auxiliary equation. That is, in place of d put m square, in place of d dash only 1. So what is the final equation? M square plus 4m minus 5 is equal to 0. So it is a quadratic equation, so factorize it. After factorizing, what did you obtain? Roots as 1 comma minus 5. So how many roots are there? 2 roots. How are they? They are real roots. So whenever the roots are real and distinct, what about the CF? We just have to write like this: z is equal to f1 of y plus x plus f2 of y minus 5x. Now going to the second part, that is to find particular integral. To find particular integral, what we have to do? We have to write PI is equal to 1 by f of d comma d dash into capital F of x comma y. In f of d comma d dash, whatever is present here, capital D square plus 4d dash minus 5d dash square. Just to substitute it. In capital F of xy place, what we have to write? Sine of 2x plus 3y. And next, what are the things you have to do here? Here in a place, what is there? 2 is there, that is the coefficient of x. In b place, what is there? 3 is there. It is nothing but the coefficient of y. After writing these terms, what you have to do? In place of d square, you have to write what? Minus a square, means minus 2 square. In place of d dash, what you have to write? Minus ab, that is minus 2 into 3. In place of d dash square, what you have to write? Minus b square. What is b right now here? Minus 3 square. So substitute all the values in the above set equation. So what did we obtain? 1 by minus 2 square plus 4 into minus 2 into 3 minus 5 into minus 3 square. Please remember that minus 3 square, not minus 3 whole square. Be very careful about it. So what are we left with finally after simplifications? 1 by 17 into sine of 2x plus 3y. So now easily we have found out the complementary function and also the particular integral. So join these two and write the general solution of the given equation. Now we shall have a quick recap of what are the things we discussed in this video. What have we discussed? We have discussed about what is meant by a particular integral, how to solve the particular integral, or when do we take the case of particular integral. Whenever capital F of x y is present, then we have to definitely go for the solution of a particular integral. And in this video, what are the methods we have discussed? We have discussed that how to solve when f of x y takes the form of e power x plus by, and whenever f of x y takes a trigonometrical substitution, whether it is sin a of ax plus by or cos of ax plus by. See, if you want to better understand these problems, please try a few more practice problems. And if this video is really helpful to you, drop a like and subscribe so that you never miss the coming lectures. More interesting lectures will come you in the next sessions. Do not miss the next sessions. Thank you all for watching this wonderful video.